What's something people don't know about Mercury? Despite being the smallest and closest planet to the Sun, it holds a secret that defies expectations. It's the closest planet to the Sun, after all, orbiting at an average distance of just 36 million miles. This proximity means it receives a significant amount of solar radiation. However, Mercury holds a surprising secret: ice. Yes, you read that right. Ice on a planet with surface temperatures that can reach a staggering 800 degrees Fahrenheit. This discovery has baffled scientists and intrigued space enthusiasts alike. This seemingly paradoxical fact is just one of the many intriguing aspects of this celestial wonder. Mercury's extreme temperatures and its icy secret make it a planet of contrasts. Mercury challenges our expectations, reminding us that the universe is full of surprises. It defies the simplistic notion that proximity to the Sun equates to uniform heat. It beckons us to delve deeper, beyond the surface, to uncover the captivating mysteries hidden within its cratered landscape. Each crater, each shadowed region, holds a piece of the puzzle. The presence of ice on Mercury is not as outlandish as it might initially appear. The planet's unique characteristics create conditions where ice can persist. The planet's axis of rotation is almost perpendicular to its orbital plane. This means that Mercury has virtually no axial tilt, unlike Earth, which has a tilt of about 23.5 degrees. This means that the polar regions, permanently shrouded in shadow, remain incredibly cold, reaching temperatures as low as -300 degrees Fahrenheit. These regions are shielded from the Sun's intense heat. These frigid traps, shielded from the Sun's relentless heat, provide a haven for water ice to exist. The ice is thought to be buried beneath a thin layer of insulating material, protecting it from sublimation. The discovery of ice on Mercury sent ripples through the scientific community, challenging our understanding of this seemingly familiar planet and sparking a renewed interest in its exploration. It has led to new missions and studies focused on uncovering more about this enigmatic world. The existence of ice on Mercury also raises intriguing questions about the planet's formation and evolution. It suggests that Mercury's history is more complex than previously thought. How did the ice get there? Was it delivered by comets or asteroids that crashed into the planet's surface, bringing water with them? Was it delivered by comets or asteroids that crashed into the planet's surface? These celestial bodies are known to carry water ice, and their impacts could have deposited ice in Mercury's craters. Or could it be primordial, remnants from the early solar system when Mercury was still forming? This would mean that the ice has been preserved for billions of years. These questions fuel our curiosity, driving scientists to unravel the intricate tapestry of Mercury's past. Each new discovery adds a piece to the puzzle, helping us understand the planet's complex history. The discovery of ice on this seemingly barren world hints at the possibility of other hidden resources, perhaps even organic molecules, the building blocks of life. These molecules could provide clues about the conditions necessary for life to develop. While the existence of life on Mercury is highly unlikely given its extreme conditions, the presence of these fundamental ingredients sparks our imagination and fuels the search for life beyond Earth. It encourages us to look for life in the most unexpected places. Mercury, the unexpected icebox of our solar system, invites us to explore its uncharted territories and unravel the secrets it holds within its enigmatic heart. As we continue to study this fascinating planet, we are reminded that the universe is full of surprises waiting to be discovered. Mercury has been known to humanity since ancient times, its presence easily discernible in the night sky. This small, swift-moving planet has fascinated observers for millennia, appearing as a bright, wandering star that dances close to the Sun. The ancient Sumerians, as early as the 3rd millennium BC, documented their observations of this celestial wanderer. They meticulously recorded its movements, noting its rapid transit across the sky and its brief appearances at dawn and dusk. Its swift movement across the heavens earned it the name Nabu, the messenger of the gods, in Babylonian astronomy. Nabu was revered for his wisdom and speed, qualities that mirrored the planet's quick journey through the night sky. The Greeks, associating the planet with Hermes, the fleet-footed messenger, further solidified its reputation as a celestial courier. Hermes, known for his swiftness and cunning, was a fitting namesake for this elusive planet. Mercury's proximity to the Sun, while making it easily visible, presented significant challenges for early astronomers. The planet's close orbit meant it was often lost in the Sun's intense glare, making detailed observations nearly impossible. The glare from our star made detailed observations difficult, obscuring the planet in a veil of light. Early astronomers struggled to discern its true nature, often mistaking it for a star or a different celestial body. As a result, much of Mercury's true nature remained shrouded in mystery for centuries. Its fleeting appearances and elusive behavior only added to its enigmatic allure, captivating the imaginations of those who gazed upon it. It wasn't until the development of the telescope in the 17th century that astronomers could finally begin to pierce the veil and unveil some of Mercury's secrets. The invention of the telescope marked a turning point in our understanding of the cosmos. Galileo Galilei, the father of modern astronomy, was among the first to observe Mercury through a telescope. His pioneering work laid the groundwork for future astronomers, despite the limitations of his early instruments. While his observations were limited by the technology of the time, Galileo's work laid the foundation for future generations of astronomers to study this enigmatic planet. His meticulous records and innovative methods inspired others to continue the quest for knowledge. Over the centuries, telescopic observations gradually revealed more about Mercury's orbit, rotation, and surface features. Each new discovery added a piece to the puzzle, slowly unraveling the mysteries of this distant world. However, it wasn't until the dawn of the space age that we could truly begin to unravel the mysteries of this elusive world. The advent of space exploration opened up new possibilities, allowing us to send probes and spacecraft to study Mercury up close. The advent of space exploration in the 20th century revolutionized our understanding of the solar system, and Mercury was no exception. Missions like Mariner 10 and Messenger provided unprecedented insights into the planet's composition, geology, and magnetic field. For the first time, we could send spacecraft on daring missions to other planets, allowing us to observe them up close and collect invaluable data. These missions revealed a world of extremes, with scorching temperatures and a surface scarred by impact craters. These robotic explorers would become our eyes and ears in the vast expanse of space, beaming back images and information that would forever change our perspective on our celestial neighbors. The data collected by these missions has deepened our understanding of Mercury's unique characteristics. Mercury, once a distant and enigmatic object, was about to become strikingly real. The detailed images and data sent back by space probes have transformed our view of this small, rocky planet, revealing its complex history and dynamic environment. Mercury is the smallest planet in our solar system, a title it reclaimed after Pluto's reclassification as a dwarf planet in 2006. Despite its small size, Mercury holds a wealth of fascinating characteristics that make it a subject of great interest to astronomers and planetary scientists alike. With a diameter of just over 3,000 miles, it's only slightly larger than our Moon. This makes Mercury a relatively small planet, but its size belies the complexity and richness of its geological and physical properties. To put this into perspective, you could fit approximately 18 Mercuries inside Earth. This comparison highlights just how tiny Mercury is in the grand scheme of our solar system. Despite its diminutive size, Mercury is a celestial heavyweight in terms of density. Its density is second only to Earth, which is quite remarkable for such a small planet. It is the second densest planet after Earth, composed primarily of iron and nickel. This high density indicates a significant presence of heavy elements, which is unusual for a planet of its size. This dense composition suggests that Mercury harbors a massive iron core that makes up a significant portion of its interior. The core is believed to occupy about 85% of the planet's radius, which is an extraordinarily high proportion. In fact, Mercury's core is thought to be larger than the entire planet Mars. This comparison underscores the unique internal structure of Mercury, which is unlike any other planet in our solar system. The core's enormous size and its composition have profound implications for Mercury's magnetic field, a feature that sets it apart from the other terrestrial planets. Mercury's magnetic field, although weak, is a significant aspect of its overall planetary characteristics. Unlike Venus and Mars, which lack a global magnetic field, Mercury possesses a weak but measurable magnetic field. This magnetic field is generated by the movement of molten iron within its core. This suggests that at least part of Mercury's core is molten and convecting, generating the electric currents needed to sustain a magnetic field. The presence of a molten core is crucial for the generation of a magnetic field, as it allows for the necessary dynamo action. Another intriguing aspect of Mercury's composition is its surprisingly thin crust and mantle. This thin outer layer is a stark contrast to the thick crust and mantle found on Earth. Unlike Earth, where the crust and mantle account for a significant portion of the planet's volume, Mercury's outer layers are relatively thin. This thinness is believed to be a result of the planet's unique formation and evolutionary history. Scientists believe that this is due to a phenomenon known as core solidification. As the core cools and solidifies, it causes the planet to contract. As Mercury's core slowly cools and solidifies over billions of years, the planet shrinks, causing its surface to wrinkle and contract. This process of contraction has been ongoing for much of Mercury's history. This process, known as global contraction, has left its mark on Mercury's surface, scarring it with vast cliffs, ridges, and scarps. These geological features are evidence of the planet's dynamic internal processes. Mercury's small size and its massive iron core have shaped its evolution, influencing its geology, magnetic field, and even its orbit. The planet's unique characteristics are a direct result of its internal structure and composition. This tiny, dense world serves as a natural laboratory for studying the processes that govern the formation and evolution of terrestrial planets. By studying Mercury, scientists can gain insights into the early history and development of other rocky planets, including Earth. Its unique characteristics provide valuable insights into the diverse range of planetary bodies that populate our solar system and beyond. Mercury's distinct features make it an essential object of study for understanding planetary science and the complexities of our solar system. Thank you for watching. If you enjoyed this video, please give it a thumbs up and subscribe to our channel for more fascinating content about our solar system and beyond.